start now. I'm going to start just finishing this connection. Okay, today we are going to cover this topic, differentials. So under these differentials, we'll cover more topics under this main topic. So first thing that I have to define is what is a differential. So we'll start with what we call a total differential. So let's say here a total differential, we are given a function fx. We are given this function here. F is a function of, okay, I want to see if this is working. Okay, we are given f is a function of x and y. Now to determine the total derivative, this is how you determine it. dz is equals to, you differentiate f partially with respect to x, you multiply it by dx, you differentiate f partially with respect to y, you multiply it by dy. This is called a total differential. Like I said in the previous class, this is very important, especially for next year. This will be your first step when you are dealing with what we call exact differential equations. So you must remember this, or you must refer to your notes next year. You can ask for these notes. Now, if our function now, it contains three variables, so dw will be, we differentiate g partially with respect to x multiplied by dx, plus we differentiate gy with respect to y multiplied with dy. We differentiate g with respect to z multiplied by dz. So this will give you a total differential for if we have three variables. So we'll continue that fashion up to the nth variable. Now, for example, they can ask you to compute the differential of, then they give z. This is z. Now, if you look at z, it actually have two functions. So this means you're going to use a product rule. Now you start by differentiating z partially with respect to x, so using product rule. So you have 2x e to the power x squared plus y squared tan 2x plus, now you keep the first term, e to the power x squared plus y squared. You differentiate tan 2x, differentiating the inner function, this gives you 2. Differentiating the outer function, you have sec squared 2x. So this is your derivative with respect to x. You differentiate z partially with respect to y. Now you can see that the second function is a function of x only, so we'll treat it as a constant. So we differentiate the first one. It's going to be 2y e to the power x squared plus y squared tan 2x. Now you write this in terms of a total differential. dz is equals to, now you can write, okay, let's write the formula first. dz is equals to, you differentiate z partially with respect to x, dx, you differentiate y partially with respect to y, dy. Now what remains now is just to substitute. You put 2x e to the power x squared plus y squared tan 2x plus e to the power x squared plus y squared multiplied by 2 sec squared 2x, close the bracket, dx plus 2y e to the power x squared plus y squared tan 2x. Okay, so this one is just multiplication. There's no need to close. So dy. So now we have to determine the total differential of this given function. So that's how you will approach it. Now, like I said, I think now I need to discuss this in detail. I'll just leave this page here. Let me see what I can do. What is it called? Okay. Now I'm going to discuss in detail. I'm focusing on explaining the theoretical part. Okay, let's say you are given this function z is equals to f, and f is a function of x and y. Now we started by determining the total differential. Now from the total differential we move to, so the total differential, let me write the total, the dz equals to differentiate f partially with respect to x dx plus we differentiate f partially with respect to y dy. Now we move to what we call a small change. So a small change, so this is how we define it, is delta z equals to f, we differentiate f partially with respect to x multiplied by delta x plus we differentiate fy partially multiplied by delta y, delta x, delta y. So you can basically, if you compare these two, this means we have a situation where delta x is approximately equals to dx and delta y is approximately equals to dy. So these two, they will basically give you this equation here. And this equation is called a small change. Now, immediately after the small change, we move to what we call the rate of change. So students, they usually have problem with formulas. Now, I wanted to put some time on these formulas. Now, to determine the rate of change, you can basically, I'll write the formula first before explaining. dz dt is equals to, we differentiate f partially with respect to x dx dt plus differentiate fy with respect to y dy dt. So this equation here gives you what you call the rate of change. Now, if you compare these two, what is the relationship between the total differential and rate of change? You can see that basically they just divided the total differential by dt. That's basically what happens. But they divide only the dx here, dy, dz. Then it gives you the formula for the rate of change. Now, immediately after this, now we go to what we call chain rule. Chain rule. So chain rule, we have two cases. We have case one. So for case one, this is the situation. Let's say you are given a function z is equals to f, x, and y, and x is itself a function of t. Let's say that's gt, and then y also is a function of t. So this is the scenario here. So if we have this situation here, now what will be the what you are looking for. We have dz dt is equals to, you differentiate z partial with respect to x, so dz or f, you can use z or f, is fine, with respect to x, dx dt, plus you differentiate z partially with respect to y, dy dt. So this is case number 1. So you can clearly see that, that's why I usually say that the rate of change and chain rule, they are basically related. This is the same equation if you look at that one. This equation here and this one. But this one, chain rule, has got many cases. This year we'll focus on only 2 cases. Case number 2. In case number 2, we have z equals to still a function of x and y. But what changes is that x now, x is a function of 2 variables. X is a function of 2 variables. So in this case, x will be g of s and t, and y is equals to h of s and t. So now, here now there are 2 things that you can determine. I can ask you to determine dz ds, and I can ask you to determine dz dt. So dz ds, it means that you differentiate z partially with respect to x, and you differentiate x partially with respect to s, plus you differentiate z partially with respect to y, you differentiate y partially with respect to ds. So this will be the solution. Now here, we differentiate z partially with respect to x, we differentiate x partially with respect to t, plus you differentiate z partially with respect to y, you differentiate y partially with respect to t. So we have 2 situations under case number 2. So I can ask you to determine one of the 2. Now the last one point that I need to discuss here is a special case of chain rule. So the special case of chain rule, it will give us implicit differentiation. Implicit partial differentiation. Let me just differentiate the partial differentiation. Differentiation. So I think I'll just write it here to save space. So you are given z equals to f, and it's a function of x and y. So in this case, y is a function of x. Okay, so how do I write that? Let me just create a new function. This is not professional. Let's say y is a function of x. Now, here, your total differential. So you use the total differential. The total differential dz is equals to, okay, for some reason, I'll prefer to use df. Let's use df because f and z are equal. df is equals to, you differentiate f partially with respect to x, dx, we differentiate y partially with respect to x, this is the case, dy. Now, if I were to differentiate both sides by dx, I divide both sides by dx, what do I get? dx, and immediately out of that, in this type of question, I'll ask you to determine dy dx. So determine dy dx. So here it means that you're going to make dy dx the subject of the formula. Now you can clearly see from here that dx and dx, they cancel out. Okay. So what remains there? What remains there? Okay, and then the other thing that I forgot to mention, which I can mention that. So in this type of a problem, we usually equate our z to 0. We usually equate this given function to 0. So what does that mean? It means that if the derivative with respect to x is basically 0, so this means we have 0 equals to fx plus fy dy dx. Now, making dy dx the subject, this means dy dx is equals to minus this guy, first derivative with respect to x over first derivative with respect to y. Now, this equation that we have here is the equation that we use to determine implicit differentiation. I write it nicely there. Implicit partial differentiation. Implicit partial differentiation. It's a differentiation. So basically this covers the whole topic. Now we're just going to solve the problems that we want to solve from the presentation. Okay. Now, this example that we have here is for small change. They say the power P consumed in a resistor is given by P equals to V squared over R watts. Determine approximate change in power when V is increased by 5%, R is decreased by 0.5%, if the original values of V and R are 50 volts and 12.5 ohms, respectively. And the answer that we're expecting to get, this is from your textbook. I took it from your textbook. What do you call it? Higher engineering mathematics. So the answer that we're expecting to get is 21 watts. So let's see if we will be able to get that. Okay. So I want to check something in my notes. The approach, how will I approach this? Okay, so this means I'll go back to OneNote to solve this problem. So P is given. P is equals to V squared over R. And then I said the formula for small change is delta P equals to, you differentiate P partially with respect to R multiplied by change in R. You differentiate P partially with respect to V multiplied by change in V. Okay. Now, if I differentiate P with respect to R, what do I get? This means here I can write this as V squared R to the power minus 1. So my answer here will be V squared over R squared, and this is negative. Okay, now if I differentiate P with respect to V, my answer will be 2V over R. Now I need to substitute. This means delta P is equals to minus V squared over R squared, and then change in R. This will be 2V over R, change in V. Now if I read the problem, they say change in R is what? What is change in R? Is minus, okay, I'll go back to the problem again, just to read it again. So the change in R, so the decrease, the change, let's see, R decreased by 0.5%, so is 0.5 over 100 of R and then the voltage is 5%, 5 over 100 of R. So that's what I'm going to use. Okay, so I have minus V squared over R squared, and they say changing R is minus, because it's a decrease, going to be minus 0.5 over 100 R what? Of R, plus, here we have 2V of R over R, and our change in V, they say is 5%, an increase of 5%, so is 5 is positive. 5 over 100 of what? Of V. Now, if we look at this equation, basically we can simplify it to negative and negative is positive. You have 0.5 over 100 plus 10 over 100. And then I can say something is common. What is common here? We have V squared over R is common. And V squared over R is basically our power, the P. Okay, so let's add these two. Let's use Mathematica to avoid calculator. This will be our calculator here. So I want to add the 0.5 over 100. I just want the value there. 0.5 over 100 plus 10 over 100. This gives me 0.105. So I have 0.105. Okay. Now multiply. So my voltage, they said, is 50. It's going to be 50 squared divided by 12.5. Now let's see what value are we going to get there using Mathematica. So we have 50 squared divided by 12.5. This gives me 200. So this means this is equivalent to 0.105 multiplied by 200. And this is equal to 21. I just have to prove that it's 21 by just doing it here. So 0.105 multiply by 200. So the answer is 21. You can clearly see there our answer is 21. So this means we have solved this problem step by step. So you can't complain that I jumped steps. So this is how you determine the small change. So I took one problem. So for you to solve this, you need to go to the notes that I've given you on calculus. There are problems there or under small change and rate of change. So it's 21 watts. We'll put the unit there. So this one also, I took it from your notes, your textbook. So it's your homework to practice this type of method. Then you go and solve this one. So here we have 3 variables. So you can just write change in Q is equals to, you differentiate Q partially with respect to L multiplied by change in L. You differentiate Q partially with respect to R multiplied by change in R. You differentiate Q partially with respect to C multiplied by change in C, and then you solve. Okay, so that's what you're going to do then. Okay, now here I'm going to relate chain rule and the rate of change, which we have already done on when I was discussing the nodes. So for chain rule, we have case 1, So we have discussed that. So this is the answer for that. Remember, you can always represent Z and F, they are equal. So where I use this F, we can also use Z. It's up to you. You can see these two are equal. Now we have an example here. They say we must determine dz dt. Okay, so this means we need to differentiate z partially with respect to x. So if you look at this function here, basically here we have to use product rule here. So it's going to be e to the power x y plus x. Now when you differentiate the index xy, the answer will be y with respect to x, e to the power xy. Now you differentiate z partially with respect to y. Let's see what we get. It's going to be, so x, we treat x as a constant, so we have x squared e to the power xy. Okay, now we write the formula dz dt is equivalent to, we differentiate z partially with respect to x, dx dt. We differentiate z partially with respect to y, dy dt. Now substituting what we have there on top, we have e to the power xy plus xy e to the power xy, and then dx dt. This means we differentiate this x here with respect to t. The answer is 2t, plus we already differentiated this one, is x squared e to the power xy dy dt. Then we differentiate this guy with respect to t. The answer is minus 1 over t squared. Okay, so now this is what we have. So in this type of question, I can also say that you must determine dz dt in terms of t. In terms of t. So in terms of t. So this means what you are going to do, where you have x and y, you will put t squared. So if that was the question, you can put e to the power, and here you substitute t squared, and here you substitute t to the power minus 1, plus substitute here also t squared multiplied by t to the power minus 1, e to the power t squared multiplied by t to the power minus 1, and everything here multiplied by 2t, plus here it's going to be t squared to the power 2, e to the power t squared multiplied by t to the power minus 1 multiplied by minus 1 over t squared. Now let's see what are you going to get here. I just write it somewhere there. So we have dz dt equals to, so if you multiply these two, we can see the base is the same at the index. You have t, so we have e to the power t plus t e to the power t, so that's what we have there inside the bracket, multiplied by 2t plus t to the power 4 e to the power t multiplied by minus 1 over t squared. So we can still simplify this further. We can multiply by 2t through there, and then t squared cancel t to the power 4 there. We end up with t squared minus t squared. So basically this is the chain rule, similar to what we have done on the single variable. Okay. Now here, this is a special case of chain rule. We have discussed how to get this formula here. Let's see if we have any example. Okay, so here they say find dy dx for this equation. Remember, If we were to use the method that we did of implicit differentiation when we were dealing with this topic, we'll get the same answer. So whether we use this method or use that method, get the same answer. But once they write use partial, if they got the word partial, this means we must use this method. So they are restricting you to use the new method. So here, the first thing you must write this function, you must write it in this form. This is equals to x cos 3y plus x to the power 3, y to the power 5 minus 3x plus e to the power y equals to 0. That's the first step. Now we differentiate f partially with respect to x. So what do we get? Cos 3y, because here we only differentiate x, we treat cos 3y as a constant, plus now we differentiate here with respect to x, so it's going to be 3x squared y to the power 5 minus 3. Okay, now you differentiate to determine with respect to y, so this will be, we treat x to be a constant, so we differentiate cos 3y. I can see we'll have minus 3. Differentiating the inner function there is minus 3x sine 3y. Okay, here differentiating, we treat x to the power 3 as a constant, we differentiate y to the power 5, so it's going to be 5x to the power 3, y to the power 4. This is a constant, so it will be 0 minus 3x. The last one is going to be plus. We differentiate this guy here, will remain e to the power y, because we are differentiating with respect to y. Now dy dx is equals to minus fx, not fx, it's a subscript. I hope you can see that. So the first derivative, and then this is what we have. Now we just substitute. So substituting there, I can see there I have 3 minus cos 3y minus 3x squared y to the power 5 all over e to the power y plus 5x to the power 3 y to the power 4 minus 3x sine 3y. So this is my solution. So you should be able to determine dy dx using partial derivatives. Okay. Now this one we've also discussed, that if g is a function of s and t and h is a function of s and t, then this we must be able to determine these two guys here. Okay. So let's see. Okay, here is an example. They say find these two guys here, this one and that one. So there's a situation where I've seen students, what do? They first substitute r and theta in what? In z, and then work the problem out, or you can do it the way we do it here. dz ds will be equals to, we differentiate z partially with respect to s. Does it contain s? Yes, because you have to substitute theta here. So basically z is equals to it contains s. You have to substitute it first here and solve. Okay, let me write the formula first. It's confusing me. Okay, I can always do like this. d z d theta d S. I think this would work. Plus dz d what? dr d what? Okay, it's confusing me. Let me look at the formula. I'm working with respect to S. So it will be the second variable, which is R. Okay. So it's going to be dr multiplied by dr ds. Okay. So this is the formula. Now let's see what we get. Now if I differentiate z with respect to z, what do I get? My answer is 3 e to the power 2r, okay, cos 3 theta. Now I differentiate theta with respect to s, this one here. My answer will be 2s over 2 root s squared plus t squared, okay, plus, now I differentiate dz with respect to r partially. It's going to be 2 e to the power 2r sine 3 theta. So that's the answer when you differentiate with respect to r. Now you differentiate r with respect to s. My answer is just t. But it seems like I'm missing something here. Okay. How many variables are there? There are 3, 4. Okay. I'm missing something here. Okay, let me check. Maybe I had to substitute first. Okay, let's check where I got it. Okay, let's check where I have made a mistake. And correct that. This is an online textbook that I use most of the time. It's a textbook. Okay, I think it's chain rule here. Somewhere here, I must case 1, case 2. So the problem we are solving, I think, is here. This is case 1. Yeah, case 2. It's exactly this one here. Okay, so let's check the solution where I went wrong. Or they went directly to the solution. I want to compare with my own, okay? So this is correct up to this point, this guy. The first two part is correct. Okay, I hope, can you hear me? Let's compare our solution with this one. Look at the first part here. Okay, so I'll make it available immediately after class, this one. So immediately after this, what they did, they substituted theta and r. Where is r? Then theta, yeah, and r to end up with this solution here. Okay, so what it means is that in our problem that we're solving now, we need to substitute. We got the same answer like this, like them exactly. We can say that 2 and 2 cancel out here, and then they have t there. We started to differentiate with respect to s first, so you need to substitute this 3e to the power 2. Where you have r, you substitute st minus t squared cos, and then for theta you substitute the square root of s squared plus t squared. Okay, then you multiply it by s over root s squared plus t squared plus 2e to the power, then you substitute st minus t squared, and then sine, and then there's a 3 there, we substitute root s squared plus t squared multiplied by t. So this will be your solution. You just need to simplify if possible. So for dz dt, you'll use the same approach. This will be the case. dz dt is equals to differentiate z partially with respect to theta. We differentiate theta with respect to t. We differentiate z partially with respect to r. We differentiate r partially with respect to t. And then you substitute. You'll end up with a solution similar to this one. So that's how they got their solution here. So you'll end up with this solution here, the one that they have here below. Okay. So this is chain rule. Okay, let's see the last part. So here we have two problems. I don't know, maybe we'll do all of them. How many minutes still left? 30 minutes. Yeah, we can do this one. Okay, the rate of change. So here they say the radius of a right cylinder is increasing at the rate of 8 millimeters per second, and the height is decreasing at the rate of 15 millimeters per second. Then find the rate at which the volume is changing in centimeter cube when the radius is 40 millimeter and the height is 50 millimeter. So what I'm going to do, the difference between centimeter and millimeters, I think, is 10. So I'll work the problem in millimeters and divide the answer by 10. Or you can convert everything to centimeters and work in centimeters. Okay, now what I need now, I need to know what are they looking for? They must give me a hint. The hint here tells me about the volume. So I need the volume of the sphere. It's what is pi r squared h. So this means I need to determine the rate at which the volume is changing, which is given by dv dt. Okay, now I'm going to differentiate v partially with respect to r and multiply it by dr dt. plus I differentiate v partially with, I think in my problem my v looks like r, d h, and then I differentiate r with respect to what? It's not r, it's h. I differentiate h with respect to t. Now let's do that. When you differentiate with respect to r, the answer is 2 pi r h, and then r dt. What is the change in r? They say the radius is changing, is increasing by 8. So this will be 8 here, plus now dv dt dh. You differentiate v with respect to h. This will give me pi r squared, and then the h dt. H is decreasing, so decrease is negative 15. Now what remains now is to substitute the value of r and h. This is 2 pi. Where I have r, I'll put 40. Where I have h, I'll substitute 150 multiplied by 8 plus pi, and where I have r, I put, is it 40 squared, and then minus 15. So you punch your calculator, your answer will be 7,2000 pi. Now here I was working in millimeters, so in centimeters, so this is, let me write the unit. So this will be in millimeter, I think it's millimeter cube. I think it's 72 pi. So you will check the difference there. Millimeter, yeah, it's 10 to the power 3 millimeter per second. So it's going to be 72, I think it's 72 pi centimeter cubed per second. So this problem is also in your textbook. There's answer in your textbook. So the difference is 10, but 10 to the power 3 is 1000. That's why I divided by 1000 here. Okay. So this is your answer. The next one is a little bit more involved, but not that much. They say write circular cone, and they're talking about the surface area. So let's check. So right circular cone is basically this guy here. This is the right circular cone, and so here is a right angle. So here we can call this guy S. And from this point to this point will be our radius R, and I think this will be the height from this point. From this point to that point we have H. Okay, now our surface area S, I'll just write SA, is equals to pi RS plus pi R squared. Okay. So this means here we have pi R. Now S, we can represent S by R squared plus H squared using theorem of Pythagoras, because this is our height here, H. So using theorem of Pythagoras, R and H, this would be R squared plus pi H, and this is the case. Okay, now plus pi R squared. Okay, now we are dealing with the rate. The rate at which S is changing, the R dt, is equals to we differentiate S partially with respect to what? With respect to R, dr, dt. We differentiate S partially with respect to H, dH, dr. So this is the formula that we use. Now let's see. Now we need to determine ds, dr. So let's differentiate with respect to R. Okay. Differentiate with respect to R. We'll differentiate this one here. So differentiating here, I have pi r squared plus h squared, okay, using product rule, plus pi r multiplied by 2r over 2 root r squared plus h squared. Okay, so I've just differentiated the first equation, this one, using product rule. We have two functions there. The last one is going to be plus 2 pi r plus 2 pi r. So this is for this guy only. Now, if I differentiate S again partially with respect to H, what do I get? So the last term does not contain H, so it's 0. So I'll only differentiate the first one. Pi r is a constant, so I only differentiate the square root. So differentiating the square root, I end up with 2 pi h r all over 2 the square root of r squared plus h squared. So I'm differentiating the root, the square root of r squared plus 2h. So when I differentiate the inner function, it gives me 2h. That's why I have 2h multiplied by pi r all over 2 the square root of r plus h squared. Now we have all what we need here. What remains now is for us to substitute these guys into this equation here. After that, you substitute into this equation and solve. Okay. The other option that we have, that's the only option in short. Now, this is what I did. I substituted what? I must substitute. You see here they give me 5 centimeter, 12 centimeter. So you convert this to millimeters, so it will be 50, and this one will be 120. So that we work in millimeters. Okay, now substituting, I think we have a calculator. You'll use your calculator there. So when I substitute here, I'll give you answers only here. When I substitute here, I end up with 5. Okay. Seems like I'm writing where I'm not supposed to write. Don't know what I have deleted there. Okay, so when I substitute r and h in this equation, I end up with 5 over 13 plus 280 pi. So I want you to check if that is the case. You just substitute for r, you substitute 50, and for h you substitute 120. Okay, and simplify, you'll end up with 5 over 13, 280 pi. Now the second one, this one here, okay, I'm checking my answer, my solutions. The second one, when I substitute r and h, I end up with 600 pi over 13. Okay, so now this means here ds dt is equals to, so here I'm going to substitute my value 5 over 13 plus 280 pi. And the RDT is what? Let's see, the tangent R is 5. So you multiply it by 5 and then plus, now here I substituted this 600 pi over 13 and the HDR is what is minus 15. Minus 15. Now my solution is approximately equals to 225.2. Now what is the unit we're looking for? This is millimeter squared per second. That's the formula for the rate. So that's my solution. 225.2 millimeters squared per second. So this is the rate of change. So this is where my class ends. Okay. Now I don't know what happened. This is how I go back to my, I need to fix that. Okay, I want to secure the recording. So I'm going to stop. So any questions under the last part of partial differentiation?
Yes, sir. Good morning.
Morning, Stole.
Sir, I just wanted to know if we are going to cover these on our fourth semester test. And
no, the answer is no. Fourth.
Okay.
No, let's come back again. Fourth. Yeah, it will be part of the fourth semester test. And integration, the fourth semester test will also include integration. I'm starting integration on Monday. So I'm done with this part of partial differentiation. The only thing that remains is for you to do activities on, remember last time I give students the calculus notes. So there are activities.
Yes,
yeah, you just go to that notes and then work on them. On the problem under this topic, yeah. So if you encounter problem, you can ask me or the tutors.
Okay, so no problem. Another thing, there's a student in our WhatsApp group that has asked for the scope of the class test that we are going to write on the 12th or on the 19th. So,
yeah, let's conclude. You are writing on the 9th. Why don't you make it 19? I think 19 will give you more. It depends. If you write it on the 12th, we have more time to revise the memo. I don't know, maybe. I don't know. So you must conclude 12 or 19. Which one do you prefer?
So myself personally, I have no problem writing on the 12th, but this is something that I can't decide on my own. I think the class rep must communicate with everyone on the group, and then everyone can reach a very conclusive decision based on when to write.
Scope, let's put the scope. The scope is one thing, is two things. It's going to be differentiation. Differentiation, how do you write that? Differentiation and its application. I think I want to limit it to that, those things. But you know that this is not only one topic. It's many topics, isn't it? The way differentiation starts and then and its application. So the other parts, the linear transformation, the orthogonal transformation, the eigenvalue and eigenvectors, the vector space. I think that I'll give you as a take home.
Yes.
Class
Okay.
test. Yeah. So this means when it says take home, it's not an assignment. I give you after class. You take it home in the morning. The following day in the morning, you bring it to my office.
Okay, sir. No problem at all.
Yeah, that's how it will work.
Okay, sir. Yeah, I think that's it from me. Thank you so much, sir.
Okay. Because it's a lot. You can't write a test of 70 marks. It's a lot. There must be a difference between major test and class test in terms of marks. Okay. Okay, let me try to get this recording and give it to you now while I'm still here. So let's check if it's working. Yeah. Okay. Yeah, I think it's okay. It's working. Okay, so you have the recording there. The other thing, let's check this PowerPoint. Did I write anything that is interesting here? But it's in the video anyway. But I can share this one also. I can just save this as a PDF. So now I must look for it now. Okay, let's do this. Okay, I think it will be available, this slide. It's the one that we're using now. Yeah, it's 15 pages. Okay. I've seen someone typing. I was waiting to see the message. So he stopped. Okay, bye. See you tomorrow then.